In the last lecture, we completed a clamper circuit. In this lecture, we'll see peak detector circuit. Peak detector peak detector circuit is basically used to give a constant output, which is the peak of input waveform. Suppose this is a peak detector and we have applied an input waveform to this VM. Then this peak detector will give a constant output which will be equal to the peak of input waveform, that is VM. So this peak detector is used to detect or to hold the peak value of input waveform. The circuit diagram is very simple and it is much like a clamper. The position of diode and capacitor are interchanged, and here we have applied a sinusoidal waveform with maximum value Vm and minimum value minus Vm. As we know that this diode will be forward biased during positive half cycle of input waveform. So when this diode is forward biased, we'll replace this diode with a short circuit and a current will flow to the capacitor in this direction, and capacitor will be charged with the polarity. And when input reaches its maximum value Vm, input reaches at its maximum value Vm, the capacitor charges with the voltage equal to Vm. Now when input falls below its peak value, suppose input is Vm minus 1 volt, the diode was like this. For this diode, at its cathode the voltage is Vm and at its anode voltage is Vm minus 1 volt, means cathode voltage is greater than anode voltage. The diode will be reverse biased and it will be replaced with an open circuit. When this diode replaced with an open circuit, now we can see that the input is disconnected from this circuit and output is equal to constant Vm. So the waveforms are like this. This is the input waveform with positive peak Vm, and we'll draw the output waveform. Initially, the capacitor voltage rises with the input voltage. When input reaches its maximum equal to Vm, thereafter the output voltage or capacitor voltage remains constant. So a capacitor is used to detect the peak of input waveform so that the output will be a constant equal to the peak of input waveform. So this is a basic circuit of a peak detector, and in this circuit we can see that the capacitor is holding the positive peak of the input. So it is a positive peak positive peak detector. The negative peak detector circuit is also similar. Negative peak detector. In the negative peak detector, the position of the polarities of diode are changed. In this circuit, the diode will be forward biased during negative half cycle, and during negative half cycle current will flow in this direction and capacitor will be charged up to this voltage Vm with this polarity, and output V0 will be equal to minus Vm. So this is a negative peak detector. We have seen this peak detector circuit because uh, we will design another circuit which is called a voltage doubler. This voltage doubler uses a clamper circuit and a positive peak or negative peak detector. So the cascading of these two circuits will help us to design a voltage doubler circuit. In the voltage doubler circuit, the first circuit will be a clamper circuit, which will clamp the input waveform to a DC level, to a higher DC level, and then the peak detector circuit will detect the peak of this clamped input waveform. Now the next circuit is voltage doubler. In the voltage doubler, first we will have a positive clamper. If we have applied this waveform at the input, this clamper circuit, which is a positive clamper, will change this input waveform to this one. The positive peak will be 2 Vm and the minimum level will be at 0. Now this output will be applied to the positive peak detector, which we have already seen. This positive peak detector will detect the peak value of input waveform, which is 2 Vm. So the output, this capacitor will be charged up to 2 Vm and output will be a constant voltage equal to 2 Vm. 2-3 times this voltage doubler circuit is asked in the gate examination in instrumentation engineering, electrical and uh, electronics engineering also. This circuit has combination of two. This one is positive clamper, which is used to clamp the input waveform so that its peak value can be doubled up to 2 Vm, and this positive peak detector is used to hold the positive peak of the waveform, which is uh, appearing across its input terminals. Now we can design one more voltage doubler in which the output voltage will be equal to the double of negative peak of the input. For this we'll require first a negative clamper. This is a negative clamper, and it will be followed by a negative peak detector, and the output will be this kind of voltage equal to minus 2 Vm. So this is a negative clamper and this is negative peak detector. Negative clamper and negative peak detector.